What is up, everybody? Today, I want to look at what I call the essence of algebra. It feels like so often I see people doing tricks with algebra. Like using numbers is just like these tricks that they do. Like there's this one
that just floats somewhere.
that you carry and you kind of deliver it to the tens place, or when you do division, you gotta like do this weird algorithm and you're, getting a remainder. I don't know. It just seems like there's so many tricks. Or like when someone subtracts a negative, they do like this keep, change, and then subtraction turns into addition.
But it doesn't.
My goal today is take all those little tricks and just kind of pull back the curtain and just show
the juice.
That way, instead of remembering the tricks, you remember the essence. So, without further ado, let's jump into it. So I want to start off by just showing the field axioms. Now, you don't need to know what that means. You just have to know that these are the laws. These are the rules that the numbers follow, the operations follow. And one thing I want to just point out is all the things we see here. So I highlighted a few key points. Notice that all the laws involve either addition or multiplication. There's no subtraction and there's no division. Check out the third axiom.
The existence of an additive inverse.
And then it shows this
junk here.
But notice what's going on. It's a number plus a negative number. Why didn't they just write subtraction here? Addition of negative numbers is a key point we have to remember. So I'm just going to write off to the side here the first observation that I made. A minus B is the same as A plus negative B. And I'm going to think of subtraction instead of this operation as the addition of a negative number. I'm going to think that subtraction is the addition of a negative number.
Moving along.
Notice the second thing we see a whole bunch of, the law of multiplication, the existence of a
multiplicative identity, multiplicative inverse,
and commutative law. But notice, where's division?
Where division at?
Does the division exist? One thing we have to remember is that anything to the -1 exponent is that number over 1. This computation we see here, we have to remember that a times 1 over a will be 1. And just think of this as 7 times 1/7 is going to be equal to 1, and that's because this would be 7/7, and 7/7 is 1. Down here again, I'm just going to write another observation. And here we have it. I just wrote is the multiplication of 1 over b. Anytime we're thinking of division or dividing something, what's happening behind the scenes is the multiplication of the fraction of that number. And for those of us who are a little bit advanced at math, maybe have a better grasp on exponents, you can think of it this way. But this won't be necessary moving forward. The good old number line. I like to think of the number line as the x-axis.
This is where the story begins.
The beginning is oftentimes the most important part. Here I'm going to start at the beginning. And the beginning of anything is
addition. 1 plus 1 is 2.
But I'm going to do it a little bit different. I'm going to think of 1 as the distance from 0. So 1 is my little orange bit up there. 1. So here I have 1. I'm going to add another 1, and I'll add one more because 1 plus 1, now we're at 2, and 1, so this is 2, and this is 3. But notice how the scale of 1 changed as well. We know that repeated addition is multiplication. So let's establish multiplication here too. We added 1 to itself. How many times? 3. Now watch how the size of 1 changed. Remember, this little orange line was 1. And now the blue line, I'm going to make 3. Notice, all I'm doing is tripling the size of the orange line. How much bigger is 3 than 1? It's 3 times bigger. Let's change these numbers. Let's say this number is 2. How much bigger? What happens when we triple 2? Turns into 6. 6 is 3 times bigger than 2. Or 2 is 1/3.
2 is 1/3. 2 is 1/3
of 6. Here's a different way to think of what's happening when we multiply. We're scaling things on some sliding scale. Instead of dividing 6 by 3, just think of what's 1/3 of 6? What is 1/3 of 6? Oftentimes 1/3 of 6 is 2. And again, that equal sign, helpful to think of that as the word is.
But wait, these are the easy numbers.
What if they're tricky? What if it's difficult?
So let's start with 30. You can ask yourself, what is 1/5 of 30? And
It's easy to do. Calculators exist.
you can just take 30, divide it by 5, and you find that 1/5 of 30 is 5. Calculators are real. And I'm not saying don't use them. I'm encouraging it. But what I want us to know is what that 1/5 is. So 1/5 of 30 is 6. And that means that if I have 2/5 of 30, it's going to be 2 times 6, which is 12. If I have 3/5 of 30, going to be 3 times 6. And so you can see how 6 is the number I'm scaling now. Once I found what 1/5 of 30 was, now what I'm doing is I'm scaling it between 0 and 30. Once I found what 1/5 of 30 is, all I have to do is scale that number between 0 and 30. 1/5, 2/5, 3/5, red fifths, blue fifths.
Is Dr. Seuss free use?
Let's say we want 3/4 of 52. What are we going to do first? Well, first I'm going to find out what 1/4 is. I can take 52, and I know half of 52 easily is 26. And then I know half of 26 is 13. And then if I want to find what 3/4 of it is, I'm going to take 13 times 1, 2, 3. So just using the number line, I get this little equation here. Now I want to work on
My big beef.
what I'm going to do is, now remember, I'm referencing this number line. Positive go this way, negative go that way. So in my mind, I'm thinking, wait a second, this is 1 plus -5. Here in blue is my number 1. I'm going to go -5 spaces. I'm going to add 5 spaces in the negative direction. Going in the negative direction 5 spaces. I'm adding a -5.
What about this, though?
That's what it is. It's -2 plus -3. The keep, change. The why. 2 negatives make a positive. Here's what's going on behind the scenes here. Remember that -3 is -1 times 3. Okay? +3 is -1 times -3. These things are just true. That's just the way it is. That's just how life goes. So what I'm going to do is I'm going to examine this region right in here. So I'm just going to put the plus sign here, wrap these in parentheses, and think of what is -3. What is -3? Well, -3 is -1 times -3. What's -1 times -3? Man, I feel like that looks familiar. Oh, we did that already. That's what it is. That's why whenever I see 2 negatives in a row, make them positive. It's not the keep, change. Keep the change in the pocket. Keep change pocketed. There should be no change here. It's one of the biggest issues I see. We're stuck like remembering all this stuff. It really is like one of the biggest issues I have in math is like everyone's stuck remembering all this stuff. And they feel like, oh, if I don't remember it right, I won't get the right answer. But what I'm telling you is that there's so much going on behind the scenes that you've been lied to.
You've been just sold these tricks.
Just showing a little video like this can help you forget the tricks.
Get the tricks out.
Tricks are for kids.
So with that, if you like this video, make sure you hit that blue thumbs up button right down there. Give this video a like. And if you're new to the channel, slap that subscribe button. Thanks for watching. I'm out.